Hi everyone. So we're going to do a few more examples looking at the types of solutions, and then we're going to move on to the next chapter called matrices. Okay, so let's look at example 1. So we've got x minus 4y plus 2z is equal to minus 2. X plus 2y minus 2z is equal to minus 3. And x minus y is equal to 4. Okay, so we want to determine what type of solution the system has. Okay, so we start by writing it as an augmented system or augmented matrix. So we have 1, minus 4, 2, minus 2, 1, 2, minus 2, and minus 3, 1, minus 1, 0, and 4. Okay, so the first step is always to get the first entry here to be a 1. Okay, so it's already a 1, so the first step is done. Now the next two things to do is to get the second row entry to be a 0 and the third row entry to be a 0. Okay, so that's easy enough to do. We can take row 2 minus row 1, and then the 1 and the 1 will cancel. So row 2 minus row 1. So let's do that. The first row stays the same, so we get 1 minus 4 and 2 minus 2. 1 minus 1, that's 0. 2 minus minus 4, that's going to be 6. Minus 2 minus 2, that's minus 4. And minus 3 minus minus 2, that's going to be minus 1. Okay, and the third row stays the same because we didn't change anything there. So that's 1, minus 1, 0, and 4. Okay, so that's done. Now that third entry in the third, so first column, third row, we need that to be a 0. So we can take row 3 minus row 1. Then the 1 and the 1 will cancel, giving us the 0 which we need. Okay, so let's do that. So we get 1 minus 4, 2, and minus 2 because the first row stays the same. 0, 6, minus 4, minus 1. The second row stays the same. And for the third row, we're going to have 1 minus 1, which is 0. Minus 1 minus minus 4, so that's going to be 3. And 0 minus 2, that's minus 2. Okay. And then 4 minus minus 2, that's going to be a 6. Okay, so we see that this first column is 1, 0, 0, which is what we wanted. So that's done. Okay, so now we can move on to the second column. So the 6 over here, we need that to be a 1. The number above it, we need that to be a 0. The number below it, we need that to be a 0. Okay, so we can take row 2 and divide it by 6. That will give us the 1 that we need. Okay, so row 2 divided by 6. Everything else stays the same. So we get 1 minus 4, 2, minus 2, 0, 1, minus 4 over 6, minus 1 over 6. And row 3 stays the same. 0, 3, minus 2, and 6. Okay, so we got the 1. Now the number above, that needs to be a 0. And the number below, that also needs to be a 0. So let's do the number below first. So we can take row 3 and minus 3 times row 2, because then the 3 and the 3, that will cancel. Okay, so let's do that. The first 2 rows stay the same. We're not changing anything there. So we get 1 minus 4 and 2 minus 2. 0, 1 minus 4 over 6 minus 1 over 6. Okay. And then we get 0. 3 minus 3, that's 0. Minus 2 minus 3 times minus 4 over 6. That's going to be 0. And then 6 minus 3 times minus 1 over 6. That's going to be 13 over 2. Okay, so we see that we have a problem here. Let's just highlight that in this last row. In the last row here, we've got 0 equals 13 over 2. If we write that last row as an equation, we get 0 equals 13 over 2. That's a contradiction, right? You can't have that. So since there's a contradiction, the system must then be inconsistent. Okay, so there is no solution. Okay, so there's all the working there. Okay, so we arrive at a contradiction. That means the system is an inconsistent system, and so we don't get any solution for this. Okay, are there any questions about this first example? Okay, let's look at the next one then. Example 2. So here we have x minus 2y plus z is equal to 1. 2x minus 5y plus 3z is equal to 4. And 2x minus 3y plus z is equal to 0. Okay, we want to determine what kind of solution we have here. Okay, so let's write it in the augmented form. We're going to get 1 minus 2, 1, and 1. 2 minus 5, 3, and 4. 2 minus 3, 1, and 0. Okay, so same thing as always. That first entry, we need that to be a 1. Okay, so in this case, it's already a 1, so we don't have to worry about that. The remaining entries here, the 2 and the 2, we want those to be 0. So let's deal with the first one. We can take row 2 and subtract 2 times row 1, because then the 2 and the 2 will cancel, giving us the 0, which is what we need. Okay, so let's do that. So the first row stays the same, 1 minus 2, 1, and 1. 2 minus 2, that's 0. Minus 5 plus 4, that's going to be minus 1. 3 minus 2, that's going to be 1. 4 minus 2, that's going to be 2. Okay, the last row stays the same. We haven't changed anything there. So that's 2 minus 3, 1, and 0. Okay, so let's look at the last row. We need that first entry to be a 0. So we can take row 3 and minus 2 times row 1. Okay, similar to what we did before, the 2 and the 2 will cancel, giving us the 0, which is what we need. Okay, so let's do that. The first 2 rows stay the same, so we can write 1 minus 2, 1, and 1. 0 minus 1, 1, and 2. And then we're going to have 2 minus 2, that's 0. Minus 3 plus 4, that's going to be 1. 1 minus 2, that's minus 1. And 0 minus 2, that's minus 2. Okay, so if we look at the first column, we get 1, 0, 0. So we're done with the first column now. Now we move on to the second column. The second entry in the second row here, we need that to be a 1. So this must be a 1. The number above and the number below, they must be zeros. Okay, so let's do the first bit. To get the minus 1 to become a plus 1, we can multiply through by negative 1. So we can take row 2 times minus 1. Okay, so first row stays the same. So we get 1 minus 2, 1, and 1. The second row is going to become 0, 1, minus 1, minus 2. And the third row is exactly the same, 0, 1, minus 1, minus 2. Okay, so that bit's done. Now again, the number above and the number below, they need to be zeros. Okay, so let's do the one below first. So to cancel the 1, we can take row 3 minus row 2. Okay, then the 1 and the 1 will cancel. Okay, but notice that everything else will cancel as well because they're identical rows. So we're going to get 1 minus 2, 1 and 1. 0, 1, minus 1, minus 2, 0, 0, 0, 0. All the entries are zeros. So full row of zeros. Okay, now we need the number above to be a 0 as well. So we can take row 1 and add 2 times row 2. Okay, because then the minus 2 plus 2, that's going to be 0, which is what we need. Okay, so this is going to give us 1, 0, and then 1 minus 2, that's going to be minus 1. And 1 minus 4, that's going to be minus 3. And then we have 0, 1, minus 1, minus 2, 0, 0, 0, 0. Okay, so now the last row is all zeros. So we know that we're going to get infinitely many solutions. So let's rewrite this in equation form to see what we can get. So the first row is going to be x minus z is equal to minus 3. The second row gives us y minus z is equal to minus 2. And the third row doesn't give us anything. So there's no other restrictions on z. So z can be any real number. Okay, now we can just leave it as z being the free variable, or you might see in other places, they'll say, let z be equal to t, where t is some free variable. Okay, so it's just a renaming. However, if we write it like this, then the solution becomes, so x is going to be minus 3 plus z, or with the renaming, it will be minus 3 plus t. Y is going to be minus 2 plus z, or minus 2 plus t with the renaming, and z is just going to be t with the renaming. And this is for all t being a real number. So in fact, we don't get one solution, we get infinitely many. So we get one solution for each value of t. Okay, so we get infinitely many. So in this case, the system is consistent and dependent. Okay, so it's consistent and dependent. Okay, any questions on this example? Okay, so everyone's all right so far. Okay, let's have a look at the last example, and then we'll move on to matrices. Okay, so example 3. We've got 2x plus y minus z is equal to 5. 3x minus y plus 2z is equal to minus 1. And x minus y minus z is equal to 0. Okay, so we want to determine what kind of solutions we have from this. Okay, so let's write it as an augmented matrix. So we're going to get 2, 1, minus 1, and 5. 3, -1, 2, and -1. 1, -1, -1, and 0. Okay, so same as always, we want this first entry to be a 1. Now we could divide row 1 by 2, that could work, or we could swap rows 1 and row 3. That could also help us. Okay, so row 1, we can just swap with row 3. That will bring up the 1 that we need. So let's do that. So we're going to get 1, -1, -1, 0, 3, -1, 2, -1, and 2, 1, -1, and 5. Okay, so I've just swapped those. Okay, so now we've got the 1 in that first position, which is what we needed. Now, the numbers below, the 3 and the 2, we want those to be 0. Okay, so that's easy enough. Since we've got the 3 there, we're going to take row 2 minus 3 times row 1. Okay, because then the 3 and the 3 will cancel, giving us a 0. Okay, so let's do that. So we get 1, -1, -1, and 0. Okay, then the 3 minus 3, that's 0. -1 minus 3 times -1, that's going to be a 2. And then a 2 minus 3 times -1, that's going to be a 5. And then -1 minus 3 times 0, that's still a -1. Okay, we haven't done anything to the last row, so that stays the same. 2, 1, -1, and 5. Okay, so now we look at the last row. We've got the 2 here. We need to get rid of that. So we can take row 3 minus 2 times row 1. Again, because then the 2 and the 2 will cancel, giving us a 0 there. Okay, so let's do that. So our first row and the second row, they stay the same. 1, -1, -1, 0, 0, 2, 5, -1. And then for the last row, we're going to get 0, 1 minus 2 times -1, so that's going to be 3, -1 minus 2 times -1, that's going to give us a 1, and the 5 stays a 5. Okay, so if you look at the first column, we get 1, 0, 0, which is what we wanted. So that part is done. Okay, now we look at the second column. That middle entry 2, we need that to be a 1. The number above and the number below, we need those to be zeros. Okay, that's the next step. Okay. So what can we do in this case? Now, we could take row 2 and divide it by 2, but then we're going to be working with fractions. So that's not very nice. Okay, it's better to work with integers. So we're going to do a bit of an intermediate step. We're going to take row 2 minus row 3. Okay, so that seems a bit odd, but let's just go with it. You'll see what I'm doing. Okay, if you want to just divide by 2 and work with fractions, that's perfectly fine as well. Okay, but I'll try to avoid those. Okay, so the first row stays the same. We get 1, -1, -1, 0. Row 2 minus row 3, we're going to get 0, -1, 4, and -6. And then the third row stays the same. We get 0, 3, 1, and 5. Okay, so why did I do that? Well, if I take row 2 minus row 3, then that gives me a -1 here. Okay, so it's close to 1, which is what we need, but that's fine because we can take row 2 and now multiply by -1. And then that gets rid of the -1, turns it into a +1, which is what we needed. Okay, so, it's 2 steps instead of 1, but now we can avoid those fractions. Okay, so let's multiply by -1. So we get 1, -1, -1, 0, 0, 1, -4, and 6. and then 0, 3, 1, and 5. Okay, so, a bit of an extra step there, but now we've got the 1, which is what we needed. Okay, next, the number above and the number below, we need those to be zeros. So let's do the number below first. Okay, so we've got a 3. We need that to be a 0. So we take row 3 minus 3 times row 2. So row 3 minus 3 times row 2. Okay, because then the 3 and the 3 will cancel, which is what we want. Okay, so let's do that. The first row and the second row, they stay the same. We haven't done anything there. So we're going to get 1 minus 1 minus 1, 0, 0, 1 minus 4 and 6, 0, 0. And then here we're going to get 13. Okay, and then this is going to be minus 13. Okay, good. One more step and then we're done with this column. The minus 1 above, we need that to be a 0. So that's easy to do. We can take row 1 and we can add row 2. Because then the minus 1 plus the 1, that's going to be a 0, which is what we wanted. So let's do that. So we get 1, 0, and then minus 5, and then the 6. Then the second row and the third row, they stay the same. So we get 0, 1, minus 4, and 6 again. And then the last row, that stays the same. We haven't done anything there. That's going to be 0, 0, 13, minus 13. Good. So if we look at the second column, we get 0, 1, 0, which is what we wanted. So the second column is now done. Now we look at the third column. We need the third entry in the third column. This over here, we need that to be a 1. So that needs to be a 1. Sorry, that's a 1 there. Then the numbers above, the minus 5 and the minus 4, we need those to be zeros. Okay, if we can do that, then the third column is done and we can just read off our solutions. Okay, so how do we get the 13 to become a 1? We can take row 3 and divide it by 13. Okay, then that will make it a 1, which is what we wanted. So let's do that. The first two rows, they stay the same. We haven't done anything to them. So we're going to get 1, 0, minus 5, 6, 0, 1, minus 4, and 6, 0, 0, 13 divided by 13, that's 1. Minus 13 divided by 13, that's minus 1. Okay, almost done. Now it's just these last numbers here, the minus 4 and the minus 5. We need those to be zeros. So let's do the minus 4 one first. So we can take row 2 and add 4 times row 3. Okay, because then the minus 4 plus 4, that's going to cancel. And we get the 0, which is what we wanted. Okay, so let's do that. The first row, that stays the same. We haven't gotten there yet. 1, 0, minus 5, and 6. 0, 1, minus 4 plus 4, that's going to be a 0. And then the 6 minus 4, that's going to be a 2. And the third row, that stays the same. Okay, good. We've got the 0, we've got the 1. Now it's just the minus 5. So to get rid of that, we can take row 1 and add 5 times row 3. Because then the minus 5 plus the 5, that's going to give us the 0, which is what we need. Okay, so let's do that. We get 1, 0, and then minus 5 plus 5, that's 0. 6 minus 5, that's going to be a 1. Okay, and then the other rows stay the same. So we get 0, 1, 0, and a 2. 0, 0, 1, and a -1. Okay, now notice the last column is 0, 0, 1, and that's a check. So that means the third column is done. Okay, and also notice we've got that diagonal that I spoke about last time with the ones. So we've got ones along the diagonal, zeros everywhere else. So we're done with our working. We can just read off the solution. So this means x is equal to 1, y is equal to 2, and z is equal to -1. So in this case, we only get one solution. Okay, so what does that mean? It means the system is consistent because we have a solution, and independent because there's just one solution. Okay. Any questions so far?
Sir,
Yeah.
can you please do an example with X, Y, Z, and W?
The 4x4 one.
Yes, sir.
It's exactly the same as this. So you just do exactly the same row operations. So let's have a look. Okay, so it doesn't matter how many variables you have, you always do the same 3 operations. Okay, so let's have a look. 2x plus y minus z plus w is equal to 0. X minus y plus z plus 2w is equal to 1. 3x plus y minus z minus w is equal to 2. And let's say minus x plus y minus z minus 2w is equal to 3. Okay, so we've got 4 variables, 4 equations. Okay, so that's our system. Okay, so we write this as an augmented matrix. So we get 2, 1, minus 1, 1, and 0. 1, minus 1, 1, 2, and 1. 3, 1, minus 1, minus 1, and 2. Minus 1, 1, minus 1, minus 2, and 3. I've got a question here. Oops, sorry. So that has only 3 equations. That is 4 equations, yeah? What do you mean 3 equations?
So yesterday's homework questions only had 3 equations.
Okay, sure, we'll just get rid of the last one then, and we can do that. It doesn't change anything, you still have to do the same operations. Okay, so let's do this one. So we need a 1 in the first entry. It's got a 2 there. The second row starts with the 1, so we could just swap rows 1 and row 2. Okay, so we get 1, minus 1, 1, 2, and 1. 2, 1, minus 1, 1, and 0. 3, 1, minus 1, minus 1, and 2. Okay, so now we need to get rid of the 2 and the 3. So we're going to have row 2 minus 2 times row 1. So the first row stays the same. 1 minus 1, 1, 2, and 1. 2 minus 2, that's 0. 1 plus 3, that's going to be 4. minus 1 minus 2, that's going to be minus 3. 1 minus 4, that's minus 3. 0 minus 2, that's minus 2. Okay, third row stays the same. So that's 3, 1, minus 1, minus 1, and 2. Okay, now we need the 3 to become a 0. So we're going to take row 3 minus 3 times row 1. Okay, so let's do that. So the first two rows stay the same. So 1, minus 1, 1, 2, and 1. 0, 4, minus 3, minus 3, minus 2. 3 minus 3, that's 0. 1 plus 3, that's going to be 4. Minus 1 minus 3, that's minus 4. Minus 1 minus 6, that's going to be minus 7. And 2 minus 3, that's going to be minus 1. Okay, good. Now the second row, that needs to be start with the 1. So we can take row 2 and divide it by 4. Okay, so we're going to get 1 minus 1, 1, 2, and 1. 0, 1, minus 3 over 4, minus 3 over 4, minus 2 over 4. And the last row will be 0, 4, minus 4, minus 7, minus 1. Okay, good. So we've got that done. Now we need to look at the top entry and the bottom entry and make those zeros. Okay, so let's take row 1 and add row 2. Okay, so we're going to get 1 minus 1 plus 1, that's 0. 1 minus 3/4, that's 1/4. That's 3/4. And that's, or let's write it as 2/4. Okay, then we get 0, 1, minus 3 over 4, minus 3 over 4, minus 2 over 4. And then for the last one, we get 0, 4, minus 4, minus 7, minus 1. Okay, now this minus 4, the 4, we need that to be a 0. So we can take row 3 minus, row 3 minus 4 times row 2. Okay, because then the 4 and the 4, that will cancel. Okay, so we're going to get 1, 0, 1/4, 3/4, 2/4, 0, 1, minus 3/4, minus 3/4, and minus 2/4. Okay, 0, 4 minus 4, that's 0. Minus 4 plus 3, that's minus 1. Minus 7 plus 3, it's 4. And then minus 1 plus 2, that's going to be 1. Okay, so that bit's done. Next, we need the minus 1 here to be a 1. So we can take row 3 times by minus 1. Okay, so let's do that. So we get 1, 0, 1/4, 3/4, 2/4, 0, 1, minus 3 over 4, minus 3 over 4, minus 2 over 4, 0, 0, 1, minus 4, and minus 1. Okay, so now we've got the 1 here, which is what we need. The next two, okay, those need to become zeros, which is what we need, 0 and 0. Okay, so I'm going to let you do that. But then what we're going to end up with is 3 equations with x, y, and z. But then w is going to be our new free variable. So if we look back over here, when we had 2 equations and 3 variables, you see how the z became our free variable because of this. Over there, we're going to have exactly the same thing here because we're going to have, let me show you for the first one, x plus 1/4 z plus 3/4 w is equal to 2/4. Y minus 3/4 z minus 3/4 w is equal to minus 2/4. And lastly, z minus 4w is equal to minus 1. You see that once you've done the last column, I'll leave that for you to do. We're left with this w, and w. So in this case, we're going to let w be equal to t, and we get infinitely many solutions. Okay, so for each choice of t or each choice of w, we get another solution for the system. Okay, so it's exactly the same as before. You just do your row operations, and then you try and solve for x, y, and z. Since we're missing the 4th equation, w then becomes the free variable. So this is the free variable. Okay, so we've got a consistent system, but here it's dependence. Okay, so we're going to have to leave it at that for today. So next week, we will start on the new chapter on matrices and matrix operations. Okay, if you do have any questions, please let me know on the WhatsApp group, or you can send me an email. Okay, so the video should be uploaded in the next few minutes. Okay, if you want to go back and watch. Okay, bye everyone.